So today we're going to be talking about inheritance, specifically the way that inheritance can go wrong. I have set up a class hierarchy involving actors and heroes and wizards and things like that that is working. It's all set up properly. And so what we're going to do is we're actually going to start with a working class hierarchy and then show what happens when you do it wrong. And you'll see how it breaks in different ways. So I've created a class hierarchy that's similar to what you have to do in your homework with a base class called actor. And then there's a subclass called hero, and then hero can have a subclass for like fighter and wizard and cleric and thief and things like that. And then there is a monster subclass also of actor, and the monster subclass can have further subclasses for goblin and orc and things like that. So all of these guys have a speak function that just basically reports what class they are and what their speed is. Because I'm also going to show you guys how to sort a vector using a custom sort function as well. So let's get going. This is all using structs. When you do inheritance with structs, the inheritance is public by default. When you do inheritance with classes, the inheritance is private by default. That's why when you do with classes, you will see public all the time. I could put it here, but it is redundant. When you're doing struct inheritance, it is public inheritance by default. Fun fact. A lot of people don't know that. So there are two rules. Let's start off with this. The learning points for today. We'll just start off with that. And then when I break things, you can tell me which of these learning points we violated, which of the rules we violated. Okay. So first of all, if you want inheritance to work properly, what you want is like when you call speak on a wizard, you want the wizard speak function to be called. You want it to say, I am a wizard. You don't want it to say, I am a hero or I am an actor, because a wizard is a wizard, right? And it oftentimes will have its own special stuff. Like wizards might have spells and fighters might have special attacks and things like that. So it's important for the right function to be called. And we're going to break that. Okay, so first of all, the first rule is always use the virtual keyword on the base class. Okay, so if you have a base class function called speak, like I do here, the function is marked as virtual. That is the rule, and I'll show you what happens when you break that rule in a second. And the other half of the rule is, this one's mandatory. You have to do this, or things will break, as I'll show you. This one is optional, but highly recommended. So you put virtual on the base class, you put override on all of the children classes. And so even though wizard is overloading hero, hero doesn't need virtual here. Some people do this. Some people will put virtual here. It's not necessary. I don't think it's particularly good style to put it there. Some people think it's good style. It's not something I care particularly about. But basically the rule is on the base class, you put virtual. On the children classes, you put override. And the override there is optional, but highly recommended, highly recommended, because if you do something like add a parameter or something here, you are no longer overriding anything down here. In order for you to override a base class function, it has to be exactly the same. And that includes things like const. If I make that not a const function anymore, we are overriding nothing now. Yep. And so you will get a compiler error, which is what you want. If you're intending to be overriding something and you're not, you need to know that. And so the override function, the override keyword, is really useful for letting you know when you're not actually overriding something that you think you are. And there's all sorts of little things that can, like, screw up your overriding. You misspell something, like that's pretty common, honestly. Or you change something in a base class, you forget to change it in the child class, it'll detect it. It's a good thing. Okay. So does it have to be const override or override const? I don't think it matters. Override const should be fine. Yeah, maybe. Nope. Okay. It does have to be const override. Good to know. Fun fact. All right. Good question. Points to Gryffindor. So that is rule number one. Okay. Rule number two is anytime you do anything with inheritance, you got to be using pointers and references. And so in CSci 40, students are like, why do I need to know pointers? Why? And the answer is, in CSci 40, you don't. Like, honestly, you don't. The only reason we teach it in CSI 40 is so that you have a little bit of an introduction, so that when you hit CSI 41, where you have to use pointers and or references for it to work, you're not completely like blindsided by it. Okay. And you also obviously use pointers anytime you're doing things with like linked lists and things like that. So, and new and delete and stuff like that. So the use for pointers is less now than it used to be. But if you're working with inheritance, pointers are going to be everywhere. Okay, so I got this whole class hierarchy, and basically each of the classes is just overriding a speak function that just basically says who he is and what speed they have. Okay, and then I've also got this function here called speaker, and let's have it take an actor. I'm going to start off with the code correct. So I'm going to start off with good code. All of the code as you see it right now is working as intended. Okay. And then I'm going to show you what happens when I break the rules. All right. So I'm going to make an actor named A, and I'm going to say a.speak. And you guys tell me, what is this going to print to the screen? So basically, speak says I am an actor with speed, whatever the speed is, random. Okay. So what is a.speak going to print? So I look specifically about having vector pointers that are mixed of different classes was super interesting. And that's what we're doing on this RPG 41 homework set. So what is this going to print to the screen? If I tell an actor to speak, it's going to say, I am a what? This is the easy one. It's not a trick question. I am an actor. Right. Yeah, just say actor. It's going to. Because all of them are like, I am an actor, I'm a monster. You can just type monster or whatever. Okay. Now, I have here a function called speaker. And I'm going to pass a to it. And so it's just going to call the speak function on the actor. What is that going to print? So this one here is going to print, I am an actor. What is this one going to print? I am a what? Good. It will print, I am an actor also. I am an actor. Doing acting. I'm an actor, I'm an actor. Okay, with whatever randomly rolled speed we got. Okay. So let's make a hero. So hero inherits from the actor class. So everything that an actor has, a hero has. So we've got like a coordinate, X, Y, and Z coordinate. And then, I don't know what W is supposed to be. Attack, I don't know. Like, hero points. How about that? Hero points. We'll start with like 3 hero points, whatever that means. Like in various role-playing games, it'll do that. And then for the wizard will. So let's have it print out. Everyone will print out their speed. Why not? So maybe if you have hero points, you get to go a little faster. How about that? Okay, so it's going to be speed plus hero points. So if you have hero points, you get a little edge. I don't know. That makes sense to me. It's a kind of a fun role-playing design. So you can get hero points for doing heroic things and give you a little bit of an edge in combat and stuff like that. So we're going to create a hero called Achilles, and we're going to say Achilles.speak. So this is going to print out, I am a what? I'm holding out for a hero, right? Okay. Good. And then if I say speaker Achilles, what is this going to print? I am a what? Now we're up here, speaker takes a actor. So is it going to call the actor I am an actor speak, or is it going to say I am a hero speak? This is an interesting question, right? So we're passing Achilles. Achilles is a hero, but when we pass it in as an actor, there's a possibility of something called slicing happening. Okay, and so let me show you what this looks like in the memory map. So on the stack, remember memory looks like this. Got this thing called the stack up top. Got like the heap down below. Heap grows up, stack grows down. Inside of main, we've got this guy called A. And he's got an X, a Y, and a Z. He's an actor. And then we just made a new guy called Achilles. And Achilles has an X, a Y, a Z, and hero points. It's not really the right pen for doing this. Okay. And so this is 4 integers, and the actor is 3 integers. And so if you were to pass Achilles to a function that takes an actor, just a regular actor, not a pointer, not a reference, what happens is the hero points get sliced off. Okay? And so anytime you have a class hierarchy, any function that takes an actor can take a hero, can take a monster as a parameter. That's why you see this code is compiling just fine. Any child of the actor class can be passed in as an actor. Now, you couldn't call something like a dot hero points. Like that does, because actors don't have hero points, only heroes have hero points. So you can't access anything in the child classes, but anything that's held in common between all of the actors, like the speak function, can be called. Now, that's if you are passing it without the ampersand there. If you have the ampersand here, this code is actually, well, let me just show you. Okay. G++ main.cc, and it says I am a hero. Okay. It worked correctly. So even though speaker takes an actor, because we use the virtual keyword, this is what the virtual keyword does, it actually called the hero speak function instead of the actor speak function. So let me show you what happens if we pass it in as a regular variable, not as a pointer or a reference. If we do that, what's going to happen is it's going to slice Achilles, which is a bit ironic maybe. And then you see what happens here. Achilles turns into an actor. Everything that made Achilles special, everything that made Achilles Achilles with the hero points and everything, all that stuff gets sliced away. So if you pass a hero into something requiring an actor, the hero points vanishes and it actually turns into an actor. And so it'll actually even call the actor function for speak. Okay, this is why we have rule number 2 here. You must always use pointers or references for inheritance to work. If you just use call by value and not call by value, call by pointer, something like that, you will slice. Okay, and so if we take a pointer parameter, you see this idiom a lot when you're working with SeaWorld. Anytime you're working in C, this is how they pass things by reference. They actually put the reference there and take a call by pointer function. That's what they call it. So now we got a pointer. What do you guys think this is going to do? What is this going to print now? I am a what? Right in the Achilles tendon. Yes, you're all correct. It will actually work correctly. Inheritance requires you to use either a reference or a pointer. So with a pointer, this works. With a reference, it works. If you do call by value, it does not work. It will slice. Okay? So this is not probably how I would do it. I'd probably do it using a reference because we're in C++. You just got to change the arrow operator to a dot. Go to the references there. Now it's working cool. All right. So you can see that Achilles is reporting that he is in fact a hero. Okay. So how else could we break this? What if we dropped the virtual keyword? And then all the overrides are going to complain. I don't want to write this. This is why we have the override keyword to stop this from happening. Okay. So it is no longer virtual. So if we do this, aha, it slices again. So what's going on here? What's going on here is the virtual keyword. What does the virtual keyword do? Now I can put everything back the way it was a second ago. What does the virtual keyword do? Well, it is a secret if statement, basically. So when you have a function that is marked as virtual, what happens is anytime you have a reference or a pointer, and you call this function here, you call speak here, it holds a mirror up to its face, and it says, who am I? What am I doing here? Who am I really? And it only does that if you have the function marked as virtual. If you have the function marked as virtual, every time you call the speak function, it looks at itself in the mirror and says, oh, I'm actually a hero. Look at you. Look at you, big boy. You're a hero. You're a hero. And so when we pass in an actor here, it looks at itself in the mirror and says, oh, I am an actor. Cool. You know, I thought I was, but I am. All right. When you pass Achilles in, it looks at itself in the mirror and it says, oh, I'm actually a hero. And it calls the hero version of the speak function. Okay. And so you can imagine every virtual function having something like this, like if pseudocode time, I am an actor, you know, call this code here, else if I'm a hero, you know, this is really bad pseudocode, but it'll give you the idea. You know, print out I'm a hero. So every time you have a virtual function, it actually looks at its own type. And it creates something called a V table, a virtual table. And it inserts an if statement in there saying, who am I? If I'm an actor, do this one. If I'm a hero, do this one. If I'm a wizard, do this one. And then it dispatches to the correct override of it. Do I call this one? Do I call this one? Do I call this one? And it's based on the type of the thing that it actually is. So Achilles is a pointer or a reference, which is a pointer, same thing. It's a pointer to a hero, so it calls the hero version of speak. You guys understand? That's, yeah, it's a super pep talk. Who are you? Who are you? You're a hero. You're a hero. Yeah. So that's why virtual is so important. If you don't do that, then if you call the function directly, like we did here, that one works. But if you ever pass it by pointer or reference to a function taking an actor, then it will just use the base actor speak function instead. And what you want is for the virtual tables to do their thing, for it to be like, oh, you're actually a hero, call the hero speak instead. You can do this for getters and setters within the base class. Every time you overload anything, you should mark it as virtual. Now, the getters and setters, probably, maybe not. I don't know. Like, are you overloading? Like, if I have an int get speed function, let's say, and get speed does what you expect, and it just returns speed. I wouldn't mark it as virtual, right? Unless there's something weird going on. Like, this is probably not ever going to get overloaded. Right? Like, why would you overload this? A getter and setter that's default, you just return the value, right? So, so you mark it as virtual final, which means it can't be overloaded, but that's maybe a little excessive. I don't know. I would just leave it like this, honestly, unless somebody's going to be doing something weird, like returning speed +5 or something. I probably would not mark it as virtual. And the reason for that is because virtual has, you can instantiate the speed, let's say, instead of warrior class, instead of virtual and override. If you want to do like a pure abstract kind of thing, where you have like a string get name equals 0 kind of thing, and then you can like overwrite it here, or something like that. Yeah, this is fine. This means this will be implemented in my children. If you do this, though, you can't make an actor anymore, right? Because it's a pure virtual abstract class. Okay. So, yeah, but like for something like just a getter and a setter, I would not. Now, here's the reason. Virtual has a performance cost. There's actually, like for a small function, like a getter, which is a very small function, the performance cost of actually doing the vtable lookup, where you're like, who am I? Who am I? Am I a hero? Am I a monster? Who am I really? That cost of like looking up who it is and dispatching the proper function can actually reduce your performance by like a lot, like 50% maybe. So if you were to just kind of casually mark this as virtual, you can actually run into like a pretty enormous speed decrease off of it. So that's why virtual is not the default. In some languages like Java was designed from the ground up to be an object-oriented programming language with inheritance built into the system, like everything is inheritance in Java. Then you don't need the virtual keyword, just everything is virtual. And yeah. Okay. That's how we create a character reference in Unreal Engine instead of casting third-person character over and over again. You can save like in Unreal Engine, you can save a pointer to somebody. Essentially, that's a reference. A reference is a pointer. So you can save a pointer to like a player, and then you don't have to keep calling get player. You can just use the pointer on it. And it remembers its type. It remembers it's a pointer to a third-person character. And then you can call the proper functions off it. Okay. Is it order n or order 1? So the vtable does, I think it's implemented as a jump table, which means it's just a little bit of algebra to dispatch to the proper thing. I don't think it actually does order n if, else if, else if, else if, else if. I believe the way it's usually implemented is that it says, I'm class number 5, and it multiplies 5 times this and jumps to the right row, and then calls that function. But that level of indirection is, that kills your performance if you have something really simple like this. So for bigger functions, virtual doesn't matter that much, but don't mark something as virtual if you're not going to override it. Okay. All right, so how else can we break this? What if we did private inheritance? I don't know. Oh, it doesn't like that. So this function here is calling Achilles, and it's not, it's not going to work. So private inheritance is just not generally done. Yeah, if you drop the virtual, it's gonna treat Achilles like an actor. If you drop the pointer or reference, it's gonna slice, and ultimately these are the rules. Okay, you guys got it? Use pointers and references always when doing inheritance, and parent class methods are virtual, child class methods are override. You guys cool with this? All right, so now let me show you how to make a vector of actors. So what we can do is make a vector of actors like this, named vec, but is this a pointer, or is that a reference, or is it a regular variable? Is this a pointer? Is that a reference, or is it a regular variable? What do you guys think? Regular variable. So this is going to copy in the actor into the vector element 0. This is going to copy in Achilles. But what happens to Achilles? Right now he's a hero, but we're putting him into a vector of actors. So what happens to Achilles? What happens to his heel? Slice and dice. Yeah, he just got sliced. Okay. Only his actor traits are saved. Yeah, he loses all of his hero points. Sucks for you. All right, so let's make a goblin named Gobbo. And we could say we can even give Gobbo speed of 40. Just for the heck of it, vector.push back Gobbo. So what is going to happen to Gobbo? What does Gobbo turn into? Sliced. He becomes an actor also. Does his speed stay at 40 though? Remember, speed is a property of actor. So if we have the goblin speed of 40, does this go away when we slice off everything that makes him special as a goblin? Yeah, his speed stays as 40. His speed stays as 40. And we can see this if we just print out everything. For const auto reference A, standard range-based for loop, by the way. For every element in the vector, we will call speaker on the A. Okay, so we're just going to have everybody in the vector. So it's going to have the actors speak, Achilles speak, and the goblins speak. And you'll see that they have all become sliced into actors. Right now, the Gobbo still has that speed of 40, right? Because that's part of the actor class. That stays. But like this guy no longer has any hero points, right? That's the artist formerly known as Achilles, right? So, so how do we do it? Well, the key is this, right? We have to use either a pointer or a reference here. Now, what would be really nice is if we could do this. Oh, not that. This. This would be amazing if we could do that. Unfortunately, it doesn't work. There's these things called reference wrappers and things like that that attempt to get references working in like in a way like this, where you could just have everything work nicely. Unfortunately, if you try doing that, it will not compile. Okay, you cannot do that. Sad. This is actually something I'd like to see in C++. So what we could do is we can make a bunch of actor pointers and then pass the pointers into these guys, but we got a little problem here. And the problem is what happens when we're having a pointer to a stack local variable. What happens when we go out of scope? What happens to Achilles and Gobbo? They vanish, right? And so you never want to do this. You never want to take the address of a stack local variable and preserve it like this. Because those variables are going to go away. And like if we do something like this, we now have a bunch of pointers and a vector to things that have been deallocated. This is really bad. And so you don't want to do this. This is really bad. This is horrible. This is actually beyond horrible because it compiles. It's fine. Like everything is fine. Look at how amazing and fine this is. We're accessing memory that's been deleted, essentially. And everything's fine. Everything's great. Everything's fantastic. This is horrible code. Okay. So let's not do this. Let's not do this at all. Instead, let me show you the proper way of doing it. And the proper way of doing it is using a shared pointer to an actor in order for incoming Byzantine error. I know. It is like you do not want to have pointers to stack allocated variables because the second you leave a function, all of those pointers become dangling. And like the data is probably even still there, and it probably will even work for a while, and then a while later it will stop working, and you will be very, very baffled and confused why Achilles turned into a turtle. Okay, so you need to hashtag include memory to get shared pointers working, and what we're going to do here is we're going to use the make shared function. We're going to make a shared actor out of this guy here, like that, and then here, not using you anymore. Make shared. This code is wrong, but it's educationally wrong. And then make shared actor. vector gabo here. And now let's have speaker take, instead of reference, put this up here and make it a shared putter vector A. And we need to make you an arrow sign. Okay, this is correct, except for the indentation. There we go. Now it's correct. So, except there's one important bug in here, which we'll see. But let's go through it first. So we are now having a vector of shared pointers. And so what this looks like is, if we were to draw this out on one node up here, we are now having instead of an array of actors, each element in the vector is pointing at something. So it's going to point at an actor A for the first one. It's going to point at Achilles. Achilles for the second one, who is a hero. And then for the third one, it's going to be pointing at Gabo, who's a goblin. Actor A, hero Achilles. All right. You guys understand? So it's a vector of pointers. It's not, I don't like it. It's actually one of the reasons why I don't like doing inheritance, is because it adds an extra level of indirection to everything you do, and just everything becomes that one step more complicated. But this is actually the best way of doing what we're trying to do here. If you want to make a vector that can hold actors, and it can hold goblins, and it can hold wizards, inheritance is never the answer. I mean, to be fair, there are some times where, like, you look at a problem, you're like, inheritance is the right answer. If you have a problem where you're making a bunch of different classes and all of them have huge amounts of shared code, inheritance is the right answer. It's not never the answer, but, like, I don't like using inheritance for this, among other reasons. The class hierarchies are the main thing. Like, I still get PTSD flashbacks from, like, my software engineering classes where we had to make these giant flow charts of all the different classes that inherit from each other and stuff like that. What we have here is a cakewalk. We only got 5 classes. Okay, so what is this going to print for the first one? So actor A, and we can even set a.speed to be 50. And then Achilles, will give him a speed of 100. He's super fast. As swift as Achilles. Achilles, if I can type this, Achilles.speed. Okay. So when we do the range space for loop, the first time it's going to grab the pointer to A. And so it's going to print out, I am an A with a speed of 50. You guys concur? Anti-hierarchy. That's funny. Now, for the second one, second time through the loop, it's going to grab Achilles. But is it going to print, I am a actor, or is it going to print, I am a hero for the second one? Place your votes now. For the first one, it's definitely going to say I'm an actor with a speed of 50. Hero? I hope hero. A lot of votes for hero. Let's find out what happens. Nope, they're all actors. Because right here, I said to make Achilles an actor. So what I need to do here is make Achilles a hero, and I need to make the Gabo a goblin. Okay, now it's going to work right. So when you do the make shared, you have to say what type you're making a pointer to. And so you want to make sure it's a pointer to a hero. Okay. It was right there in front of you the whole time. Open your eyes. Okay. And so now I'm an actor, I'm a hero, I'm a Gabo. And Achilles got his little speed boost from his hero points. So everything looks good. This is actually complete code. This is correct code. In this vector, you can have every single type that inherits off actor in it. You can have wizards and goblins and toast. I don't know why you'd make a toast class. Wizard, whiz, and we can push vector dot push back, make shared wizard, whiz, and so this will make a wizard with a random speed of 18, I guess. Okay. So there is one last thing that we need to talk about today, and then we should actually talk about the code sharing a little bit too. And that is, how do you sort these guys based on their speed? Okay, so what we really want to do is be able to say vector, sort the vector, right? So sort vector.begin, vector.end. We can't though. This won't work. If we sort it, you'll see it did something, but it was not like what we thought. Because what we want is for it to sort on speed, right? And it's not. Right now it's sorting on, I don't know, probably the memory address or something like that. You overloaded the less than operator. Yeah, but does that work with the shared pointer? So what you need is a comparison function. There's actually different ways of doing this. Megan, I know how much you love lambdas, so if you like, I can do this with a lambda, or I can do it with a regular function. Which one would you prefer, regular function or lambda? Yes, all right, fine, regular function it is. All right, so we're gonna make a function, a comparator function. It's gonna return true or false if something's less. And I'm gonna call this cool kids can sort. And it's gonna take in a const reference, const, shared pointer to actor by reference left-hand side, const shared pointer to an actor by reference right-hand side, and I will return the left-hand side's speed is less. You guys hear that? Weird. Okay. Less than right-hand side speed. I hear an airplane. Yeah, that's not an airplane. I hear screaming and static, so I'm not really sure what's happening back there, but it stopped, so either my daughter is dead or everything's fine. So, but anyhow, so if we have a point, because we're sorting a vector of shared pointers, right? Like we're sorting a bunch of pointers, and so by default it sorts them probably by like memory order or something, which is wrong. It just isn't useful. What we want is to be able to sort it based on the speed of each of these guys, right? So if Achilles is faster than the Goblin, we want Achilles to go first. Abracadabra. Yeah. And so we do this by simply returning if the left-hand side speed is less than the right-hand side speed, the less than operator returns true or false. I have seen students say, if left-hand side speed is less than right-hand side speed, return true. And that's just way extra. You don't need to do any of that. This is it. So now we've got a comparison function, and we can pass in a comparison function as our third parameter here called cool kids can sort. Note that you actually don't put parentheses there. Look at that. Normally function calls have a parentheses on them, right? No parentheses. We're actually passing the function itself as a parameter to sort. So sort is taking a function as a parameter. We're passing the name cool kids can sort to it. And then it's going to call cool kids can sort on all the elements of vector in order and sort them from least to greatest in speed. And so you can see if we do it now, we now have the wizard with a speed of 18 going last. Well, first, I guess, because we put it first. And so it's going from lowest speed to highest speed. But for the homework assignment, we want highest speed going first, right? So how do we do that? How do we make it so that we have the Achilles go first, the fastest person go first, and the slowpoke wizard go last? Play an Uno reverse card. You want me to just switch the alligator so the alligator, instead of eating things this way, is eating things this way? I could. People kind of get confused at you, though, if your less than operator does a greater than. I don't know. Yeah, I mean, sure, that'll work. So now Achilles is going first. I personally wouldn't do it that way. For the simple reason that usually your comparators inside of like an operator less than, the operator less than member function is like the most important one. All right, you will see operator less than functions everywhere, and in my opinion, it should do a less than because it's called operator less than. But I mean, you could do it. You could play your Uno reverse here. That's fine. The way I would actually do it is I would have the vector itself sort backwards. So I'd sort the vector from reverse begin to reverse end. And then now it will sort greatest to smallest without having to make your less than operator greater than operator. You can. Nobody's going to stop you. It's a free country. But the maybe more proper way of doing it is to do sort from the reverse begin to the reverse end. And so it sorts it backwards. Or you could, if you like being inefficient, you could always do a reverse vector.begin, vector.end, and that will flip all of the elements in the vector as well. So that's the third way you could do it. Okay. I personally would not do that. The way I would personally do it is like this. So learning how to make your own comparator function like that, super useful. At some point we'll have to have a talk about lambdas. So we can see how to do this all in one line, but it's fine. It's good enough for now. Okay, so that is inheritance. This code is available. Copy main.cc into public. Inherit, why not? .cc. So if you want a copy of it, copy /public/inherit.cc to your current directory. I'll throw this up on Discord for you. There you go. You get a copy of the source code from today. And that is like a pretty good chunk of what you're looking to do for the homework assignment, right? You've got to create a class hierarchy. You've got to do virtual and override and shared pointers and a vector of shared pointers and stuff like that. The main question I was actually getting in the previous class was like, all right, how do we actually work together on, like, how do we collaborate? Okay. And so Min Curly is putting together a video on GitHub and like how to set up a GitHub repository and how to share things on GitHub. Git and GitHub are sort of like the standard. Like there's no other way of putting it. Like if you're a computer science major, you have to know how to use GitHub. You have to know how to use Git. You have to know how to collaboratively work on people and do PRs and pulls and pushes and all this kind of stuff. It's kind of required. However, for this assignment, it's optional. You can use it if you want to, or you can not. You pull header push it. It's funny. It kind of depends. This homework assignment was structured such that, and there's a reason why I have a limit of a group of 3, and the reason is it's really structured in such a way that it breaks nicely into 3 pieces. So I am glowing now. Look at this. So one of the pieces is working on the map code. One of them is working on the inheritance, shared pointer stuff. The other one's linked list stuff. And so you've got 3 big pieces of code. You can have them in 3 separate files. And then on GitHub, you can have one person working on main.cc. And every time they update it, it goes to GitHub. And then the other people can pull it down. Another person's working on map.h. And they can, when they got a new version, they can push it up into the cloud. And then the other people can download it. That is certainly one way of doing it. By the way, if you're not on a group right now, you need to go to the people section and then click on the RPG 41 groups and add yourself to a group. Ask if, talk to people online. You have to be in a group for this assignment. Bop it. I remember that thing. Yeah. So, the push it, pop it, whatever. Yeah. So, make sure you're in a group. Make sure you're on the projects, people, groups, RPG 41 projects. Make sure you're in a group with your group there. Crush it. Yeah. Have a crush-tastic day. Okay. The other thing I wanted to mention is if you're all working together in one file, like if you're working collaboratively on one file, the Git system doesn't work very well because you're going to get merge conflicts left and right. Like every time you submit something, if somebody else has edited it, you get what's called a merge conflict and you have to handle it, and it's really annoying. Git is not really designed for multiple people editing the same file. If you want to have multiple people editing the same file, however, you can do so. You can do so using VS Code, which Visual Studio Code. I don't like calling it Visual Studio Code because it makes it sound like it's Visual Studio. It's not. It's its own separate project. So I don't know. Here's some JSON file I was messing around with, and so right here you can see I've got a button called Live Share. And so what I could do is I could start sharing my my session here. And so I can click share, and then I can invite my partners to join in on editing this file. They, on their side, click join. You guys are smart. You can figure that part out, I'm pretty sure. You join in on their session, and then all of you guys have the ability to like work together on editing a file. And so you get that by going to the extensions section here. And inside of extensions, there is a extension called Live Share Summer. How many extensions do I have, my lord? There it is, Live Share. So you need to install that if you want Live Share to work. There's also a plugin that allows you to connect to the server remotely through SSH. So you can actually see all of your files in SSH there and double click on it and open up the file on the server. You're actually editing the file on the server. You can edit it on your home machine using VS Code, and you can share your session and have your friends work with you on that. So that's how I would do it myself. Some students in class are like sharing their passwords with each other, which is a thing, I guess, you can do, I guess. Not recommended. I mean, it depends how much you trust your partners, I guess. But this way is more secure. And so you can connect to the server using this, and it'll pull up your whole file directory and stuff like that. So pretty cool stuff. I like VS Code. I also have Vim mode for VS Code, so I get the best of both worlds as well. All right. So it's a dangerous game, yeah. So that is class for today. Work the last 25 minutes. Just work with your groups. And if you have any questions, ask me. All right. Peace out, everyone.